Assalamualaikum. My name is Nur Najwa Afifah binti Abdul Munir. My student ID is 2022875082. So, today I'm going to present what is thermochemistry. Before we start, what will we can learn from this topic? First, the introduction and definition of thermochemistry. Second, the law in thermochemistry. Third, thermochemical reaction. Fourth, important subtopic for calculation. And lastly, types of heat. Thermochemistry is the study of the heat energy which is associated with chemical reaction or phase changes such as melting and boiling. Thermo means relating to heat, and chemistry is the study of molecule and reactions. A reaction may release or absorb energy, and a phase change may do the same. Thermochemistry focuses on the energy exchange between a system and its surrounding in the form of heat. Thermochemistry is useful in predicting reactant and product quantities throughout the course of a given reaction. Second, the laws in thermochemistry. Thermochemistry rests on two generalizations. First, Lavoisier and Laplace law in 1718. The energy change accompanying any transformation is equal and opposite to energy change accompanying the reverse process. This is the picture of Antoine Laurent de Lavoisier and Pierre Simon Laplace. Second is Hess law. Hess law of constant heat mentioned in 1840. The energy change accompanying any transformation is the same whether the process occurs in one step or many. Using Hess law, when two or more thermochemical equations are added, the enthalpy change of the resulting equation in the sum of those for the added equation. Third is Gustav Kirchhoff. He showed in 1858 that the variation of the heat of reaction is given by the difference in heat capacity between the products and reactants. Integration of this equation permits the evaluation of the heat of reaction at one temperature from measurement at another temperature. Fourth is Joseph Black. He had already introduced the concept of latent heat in 1761, based on the observation that heating ice at its melting point did not raise the temperature but instead caused some ice to melt. In the first law of thermodynamics, it says energy can be converted from one form to another form, but it is neither created nor destroyed. Second, energy can be transferred between the system and surrounding. Third, chemical energy is converted to heat in grills. Fourth, sunlight is converted to chemical energy in green plants. And five, there are many examples of conversion of energy from one form to another form. Third is thermochemical reaction. Thermochemical reaction is the balanced chemical reaction indicates the physical state of all the reactants and product and also indicates the heat change known as thermochemical reaction. The thermochemical reaction have two types. It is endothermic reaction and exothermic reaction. Endothermic reaction is absorb energy from the surrounding. It is because the products are higher in energy than the reactants. If more heat is absorbed, then the product form will be less stable. Examples for endothermic reaction is sublimation of dry ice. It is a straight phase transition from a solid to a gas without going through a liquid step intermediate. Second is photosynthesis. It is because sunlight energy is absorbed by the green plants chlorophyll during the process. Third is dissolution of sodium chloride. If we dissolve it in the water will become slightly colder due to the energy absorbed by the salvation of the ions. Exothermic reaction is release energy to their surrounding. It is because the products are lower in energy than the reactants. If more heat is involved, then the product form will be more stable. Examples for exothermic reaction is combustion. This is why the burning fuel like wood or gas give off heat that keeps a house warm. combustion reactions don't always appear with visible flames, but they do always consist of the reaction of a substance with oxygen. Second is rusting. The oxidation of iron metal to form iron oxide or rust is also an exothermic process. And third is respiration. During respiration, carbohydrates present in food are broken down to form glucose. Glucose combines with oxygen in the cell of our body and provides energy. This is the reaction energy diagram. When the staircase goes down, it releases heat and less energy, and it was exothermic. When the staircase goes up, absorb heat and more energy, it was endothermic. Change of state also involved heat. When solid to liquid was melting, when liquid to gas was evaporation, and solid to gas is sublimation. This three was endothermic. But for exothermic, gas to liquid was condensation, liquid to solid was freezing, and gas to solid was deposition. System is the particular item or collection of items that we are interested. Surrounding is everything that is not included in the system. For examples, if the system is 1 mole of gas in the container, the inner wall of the container is known as the boundary. So the boundary meaning is separates the system and the surrounding. So everything that is present outside of the boundary is considered the surrounding, which will include the container itself. So, systems have 3 types. It was open system. An open system can exchange both energy and matter with its surrounding. The stovetop is a good example of the open system, as the water vapor and heat can be lost to the atmosphere. Second, closed system can exchange only energy with its surrounding, not matter. When we put a very tightly fitting lid on the pot, it will be considered as a closed system. Third, an isolated system cannot exchange either matter or energy with its surrounding. A perfect isolated system is hard to come by, but an insulated drink cooler with a lid is conceptually similar to a truly insulated system. The fifth is important subtopic for calculation. There are 4 types of heat. It was heat of displacement. The heat of displacement is the heat change when 1 mole of metal is displaced from its salt solution by a more electropositive metal. Second is heat of neutralization. Heat of neutralization is the heat change when acid and alkali solution react to form 1 mole of water. Third is heat of combustion. Heat of combustion is the heat released from the complete combustion of 1 mole of a substance in excess oxygen. Lastly, it was heat of precipitation. Heat of precipitation is the heat change that occurs when 1 mole of precipitate is formed from its ion in an aqueous solution. 3 formula that we will use to do the calculation is when to calculate the mole of solution is N equal to molarity multiply volume of solution divide 1000. When to calculate heat change is Q equal to mass of solution multiply with heat capacity multiply with temperature. To calculate heat of solution is delta H equal plus minus heat divide mole. That's all from me. Thank you very much for those who watching my video. I hope that my video can help you guys to remember more easily.